I find that most people who study consciousness have a dislike for institutionalized religion.
Yeah.
But they like spirituality in some way, shape, or form.
Yes,
right.
Exactly.
So why don't you give the audience a Cliff Notes version of your theory?
Okay. Well, I got interested in the problem of consciousness when I was in undergrad. I took a philosophy of mind class. I was a chemistry, physics, math major, pre-med. It was also the late 60s, and we did things then that people did then. And there was a lot of political turmoil, social unrest, as you might imagine. And I got really interested in this philosophy of mind class, but went to medical school. And in medical school, none of the particular specialties. I like the brain mind problem, but neurology, psychiatry, neurosurgery didn't appeal to me in terms of a lifestyle and stuff to do. I stumbled into anesthesiology, but while I was still in medical school, I did a research elective thinking I might like academics, and was in a cancer lab studying cell division, how cells divide, mitosis. And the chromosomes, the genes are pulled apart by these structures called mitotic spindles made of microtubules, and that perfectly separates the chromosomes, the genetic material. And everybody else in the lab, I'm pretty sure, got into the genes and went on to the genetic engineering and all that. But for some reason, I got fixated on these structures that pulled apart the chromosomes. And if they didn't do this delicate dance perfectly, the genetic material would not be perfectly divided, and you'd get abnormal mitosis, you get maldevelopment, you get cancer, and so forth. So I got interested in the structures that did the mechanical movement. And at that time in the early 70s, it was appreciated that they are also in neurons. The neurons were full of them, and their structure was revealed when they had a lattice structure. And that looked to me something like a computer matrix, because I was trying to figure out how computers work. Computers were new to me anyway back then in the early 70s. So I was interested in consciousness. I looked inside neurons, and there was all these structures that looked like little computers. So I got the idea that these microtubules, as they were called, might be processing information and subserving consciousness at a level below neurons. Because, as you know, almost everybody else thinks that the brain is is a computer of neurons, each neuron acting as a simple on-off switch, yes or no, a bit, a one or a zero. And if you get enough complex computation among neurons, you get consciousness emerging in some way. But yet there were single cell organisms that do very clever things. They can swim around, find food, find a mate, have sex, learn, and so forth. They were a single cell. So if a single cell paramecium can do that, for example, I thought it's kind of an insult to a neuron to say it's just a one or a zero, depending on whether it fires or not. And so I got interested in these microtubules inside neurons. So a couple of years later, when I was looking for a specialty to do in medicine, I thought about doing pure research and decided against it. But I stumbled into anesthesiology because the guy who would become my future chairman, a guy named Bernal Brown, a really brilliant and charismatic character, became a good friend of mine and my mentor, said, if you want to figure out consciousness, figure out how anesthesia works. And two, here's a paper on showing that anesthesia acts by depolymerizing microtubules that you're so fond of.
What does depolymerizing mean?
It means they fall apart. They disassemble. So microtubules are lattice polymers of individual proteins called tubulin. Each tubulin is just one protein, like a peanut-shaped protein. But by entropy, this is really weird how entropy drives something so elaborately self-organized. They self-assemble into these hollow tubes and grow like girders or scaffolding. It's like
right. I was watching this talk by Anirban, I believe.
Anirban Bandipati, yes.
Right.
And they self-assemble and they grow cells and they make neuronal connections and they do everything in terms of cell movement, cell organization. So so if you give enough anesthesia, and it turns out it takes about 5 times as much anesthesia to cause them to disassemble, to depolymerize to go from these elaborate polymers structures into the individual proteins. Enough anesthesia will do that. Well, that's about 5 times the anesthesia you need to cause unconsciousness. So fortunately, we don't cause our microtubules to fall apart. We just affect them in some more subtle way, fortunately. Although too much anesthesia can do that.
Mm-hmm. Mm-hmm.
So anyway, Bernal, my future chairman, said, you can figure out consciousness. It has something to do with microtubules. It's a lot of fun and it's pretty good money. So that was a long time ago, and I went in anesthesia, and here I am 46 years later, still doing it clinically and still enjoying it. And the research has, given me an opportunity to kind of go where I want to go.
Then you started collaborating with Penrose, and I'm curious about the practical aspects of that. We can talk about it later, but I'm super curious to know, what is it like to collaborate with Penrose? How do you do it? Do you use a whiteboard? What's an example of a problem that you've tackled together recently? But we'll talk about this. So you encountered Penrose.
I should say, before I get to Roger, I should say that I spent about 20 years working on microtubules as classical information processing devices, going around to artificial intelligence meetings, neural net meetings, neuroscience meetings, saying, hey, to understand the brain, you can't just think of the neuron as a one or a zero. You got to go into the deeper level and get into all this additional information. So, for example, the AI singularity people were saying, well, you have 10 to the 11th neurons are switching at about 1,000 per hertz, about 100 or 1,000 synapses, 100 hertz, give you about 10 to the 16th operations per second. And Curt's while in the singularity were saying, well, when we get to 10 to the 16th, we'll have brain equivalence and consciousness. But I said, well, no, if you have the microtubule subunits, about 1 billion of them or per neuron, switching at 10 megahertz, you get 10 to the 16th operations per second per every neuron. So the goalpost for AI was, I was pushing it way down the field. And they didn't like that. They said, go away, you bother us. What do you know?
Because they wanted the singularity to happen in their lifetime?
Exactly. Give them another couple billion and they'll have a brain equivalence in another few years. So I thought that was BS. And I thought their approach to the brain was an insult to the brain, an insult to neurons. And I was going around doing my thing, being a pest. And then one day somebody asked me a very good question. He said, let's say you're right, wise guy, wise ass, and all this is going on. How does that explain consciousness? How does that explain, love, joy, feelings, pinkness, envy, taste, what later became known as the hard problem according to David Chalmers. And I was a bit stunned. I had to admit they were right. I really didn't know. And I had enjoyed being a pest, but I didn't really have a solution other than we had to look deeper. And the same person suggested I read this book by Roger Penrose called The Emperor's New Mind. And I had vaguely heard of Penrose, but I didn't really know his work. He wrote the book in 89, and I think I read it in 91 or so. And it was quite a tour de force, as you may know. It covered the main point was, it started off through Gödel's theorem, arguing that consciousness requires something other than computation.
Other than what we think of as classical computation? Or just other than computation?
Even quantum computation, that there had to be something else. Because Gödel's theorem, to prove a theorem in mathematics, you have to be outside the computational system. So we extrapolated that to say that for understanding, for us to know anything, we need something outside of the computational system of the brain. Basically, the neurons fire and not fire. And I didn't follow all. It got into the weeds in terms of philosophy and mathematics. It kind of lost me, but intuitively, I felt he was onto something, and he was at least questioning and had the same gut feelings that I did, that there was something more to it than that. And but his answer, what that something was, what the missing ingredient was, got into quantum physics and a self-collapse of the wave function and his own theory of the measurement problem. And in quantum mechanics, as you may know, you can have superpositions of multiple coexisting possibilities. Things can be in two states or places at the same time. And yet when you measure or observe them, they become one or the other. So the very act of measurement, or some people thought the very act of conscious observation, seemed to cause collapse of the wave function. And the other idea is that each possibility coexists and continues and forms its own universe, or that decoherence does it, or the Bohm theory, or this or that. And they all have their flaws and they all have their appeals. But Rogers was that, well, the first thing he did that was really kind of mind-blowing, and still is after all these years, is that he explained superposition, which nobody else has even attempted to do, as far as I can tell. So the question is, how can something be in two places at the same time? How can it be here and here, the same thing in two different places? And he solved that by resorting to general relativity, by saying that as you know, for very large objects like the sun, there's curvature of space-time. This goes back to Einstein's general relativity. And so Einstein had predicted that a star behind the sun could be visible in an eclipse because the space-time curvature would bend the light around the space-time curvature, and we would see it even though we knew it was behind the star. And in 1919, Eddington went to the top of a mountain during an eclipse and proved Einstein right that there was these big curvature in space-time, and we could see these stars behind the sun in an eclipse. So basically, Einstein equated mass with curvature in space-time geometry for large things. Roger applied that to small things and said a small thing like a quantum particle, a proton, an electron, or something at the quantum level has a very tiny curvature. And so if it's over here, there's a curvature going this way. If it's over here, there's a curvature going this way. So it being in two places at once was actually two separate curvatures, a separation in space-time. So the fundamental level of the universe that he called space-time geometry, and which he cleverly portrayed as these two-dimensional sheets, could separate. And you could imagine that if they continue to separate, each would have its own universe and we'd have multiple worlds. But he said these separations were unstable, and after a time t would self-collapse to one or the other. And t was inversely related to the amount of separation. So a very large separation would self-collapse quickly, and a small one would take a long time. And here was the kicker, and when that collapse occurred to one or the other, there was a moment of consciousness that was created or occurred or emitted, depending on how you want to describe it. So this was the opposite of the idea that consciousness causes collapse. In Roger's view, collapse occurred spontaneously due to this property of the universe and created consciousness, caused consciousness, almost like a quantum of consciousness, a quantum event. And so he turned the so-called Copenhagen interpretation, and consciousness causes collapse, around and said collapse occurs spontaneously and causes consciousness.
If you enjoyed this toe clipping, then the full video is linked in the description. You should also sign up for Toe Mail, which is again in the description and the pinned comment. You'll receive immediate access to all exclusive updates from the Theories of Everything podcast. It also helps me communicate directly with the core toe community. You'll also receive my top 10 toes. Think of it as the intellectual version of Quentin Tarantino's Obsession.